Trigonometry, lesson 6.3, properties of trig functions. So, this all comes from the unit circle, the properties of the trig functions. On the unit circle, the coordinate of the sine is, coordinate on the unit circle for sine is the y coordinate. I'm going to erase this, I wouldn't bother redrawing it. Let's just go out, I don't know, pi over 6. The coordinate is root 3 over 2, 1/2. So that sine of pi over 6 is 1/2. It's the y coordinate. Cosine is the x coordinate. Tangent is y over x. All right. As a reminder, the domain for sine. What can we put in for sine? We can put anything in for sine. We don't have any problems whatsoever. It's all reals. I'm probably going to start making a habit of writing things in interval notation. The range is kind of cool. Never gets lower than -1, never gets higher than 1. Think about that. Sine gets up to 1 at 90 degrees, pi over 2, and then it gets down to -1 at 270 degrees, 3 pi over 2. Never gets higher than lower, and we're going to use that to graph. Never gets higher than 1, never gets lower than -1. The reciprocal, we already know, is cosecant. And I'll write it both ways. That's really it. Cosine, same. Same. And the reciprocal is secant. Tangent. Domain is the same. I can put anything in for tangent. Anything. It's not going to blow up my calculator. However, the range, actually I can't put anything in. What am I thinking? Domain is all reals where your x value does not equal. Can't divide by 0. Where does cosine equal 0? At pi over 2, and then every pi after that. I love writing that. I'm sorry, I know it's confusing. I can't help myself. It's cool math. What did I just write? All reals. I'm going to erase this in a second. All reals where x does not equal pi over 2 or any pi over k where k is all integers. So k could equal 1, 2, 3, -1, -2, -3. That is the domain for tangent. The range for tangent is -infinity to infinity because it does go up forever and down forever. And the reciprocal is cotangent. Cosecant goes with sine, so it's 1 over y. Secant's 1 over x. Cotangent's x over y. I have to really think about these. It's kind of annoying. I don't like it. Cosecant is just like, cotangent, which we'll come back to. Let me do secant because can't have a 0 on the bottom, can't have a 0 on the bottom. So it's going to be the same as tangent. Cosecant, all reals, where does sine equal 0? At 0 and pi, so it's at 0, I could write it as pi. I think I'll write it as pi, it doesn't really matter, plus pi k. So pi, 0, -pi, pi, 2 pi, 3 pi, 4 pi. K is all integers. The range is a little odd. It's going to start at 1 and go up. It's going to start at -1 and go down. So negative infinity to negative 1, inclusive, union 1 to infinity. Cosecant of theta is 1 over sine of theta. Secant, same deal exactly. And secant of theta is 1 over cosine of theta. Cotangent is going to have the same as cosecant because that's where the y can't equal 0. All reals, x cannot equal pi plus pi k. Notice k can equal 0. K is all integers. Cotangent has the same range as tangent. Goes up and down forever. And it's, of course, the reciprocal of tangent. That's a lot of nonsense. I'm just prepping you for the graphing aspect of the trig stuff. Don't get hung up on that. We'll talk about it more, but just understand it all comes from the unit circle. That's why we do that unit circle early, and I really want you to know it. Periodic functions is a big deal to a lot of people. It just means we get back to where we start. You already should have this knocked out by using the unit circle, because the unit circle just keeps going around and around. Start at 0, you end up at 2 pi, you end up at 4 pi. You're just repeating. For this, sine, cosine, cosecant, and secant all repeat every 2 pi. Now, it's very odd, but tangent and cotangent repeat every pi. You might say, that makes no sense, in which I would say to you, yeah, I'm not going to disagree with you that that doesn't seem to make any sense. But if you look at the unit circle and think about it, it repeats for tangent and cotangent. First quadrant is positive, second quadrant is negative. Here it's root 2 over 2, root 2 over 2, tangent's 1. Here it's negative root 2 over 2, root 2 over 2, tangent is negative 1. Down here it's negative root 2 over 2, negative root 2 over 2, tangent is 1. Hey, we're repeating. And when you play with this with graphing, you will see it's just constantly repeating. So, now the fun part. This is just a taste, and then we'll really crank into this. Triangle. Pick an angle. I'll call it X, even though we don't want to call it anything. Opposite, adjacent, hypotenuse. Let's do sine squared. Sine of X is opposite over hypotenuse. Cosine of X is adjacent over hypotenuse. Square them. Opposite. No, I don't want to do that. I'll come back to that. Let's just do a squared, b squared, c squared. Opposite squared plus adjacent squared equals hypotenuse squared. Pythagorean theorem. Divide them all by hypotenuse squared. And you'll see that you have opposite over hypotenuse, adjacent over hypotenuse. So you basically have sine of theta squared plus cosine of theta squared equals 1. This is the first trig identity, first Pythagorean identity for trig. Notice how we write it. This bothers people because when you put it in your calculator, you have to do it like this down here. but we will actually say sine squared, cosine squared, because we want to avoid the confusion. We don't want you to do this. Is that all of it, or is that just theta? So to avoid that confusion, we write it as sine squared, and we say it is sine squared. But when you put it in your calculator, you have to put it in like this. All right? Practice that at your leisure. So now we can create the other identities. Let's divide by cosine squared theta. We get tangent squared theta plus 1 equals secant squared theta. I don't believe I have any of these memorized. I can quickly derive them. It's really not that hard. Divide everything by sine squared theta. And we get 1 plus cotangent squared theta equals cosecant squared theta. So these are identities, and you can use them to solve things. We're going to use these much more when we get to trig identities. For now, just looking at things. You look at this and you go, I don't know what's going on. Sine squared of pi over 12. Oh, secant is the inverse, so we can write this as cosine squared of pi over 12. Say equals 1. Not sure, go put it in your calculator. Put it in radians, although in this case it really doesn't matter. That's a 12 over here, excuse me. And it's going to work. You can also do it with this. Given sine of theta, yada, yada, yada. Sine of theta equals 1/3 sine squared theta plus cosine squared theta equals 1. 1/3 squared plus cosine squared theta equals 1. 1/9 plus cosine squared theta equals 1. Subtract 1/9, get 8/9. Take square root, I get cosine of theta equals 2√2 over 3. And since we put that radical in, I got to show another step. We put in a square root. We have to put a plus or minus. But look at what the problem told us. Cosine of theta is less than 0, so cosine of theta equals negative 2√2 over 3. How do we find tangent? Tangent of theta equals 1/3 sine over cosine, negative 2√2 over 3. Multiply by √2 over √2. Tangent of theta equals negative √2 over 4. I'm not going to find the other 3. Flip them and you got it. I might actually throw it up on the board in a second. So I said to do this 2 different ways, because I would never do it this way. I think that's terrible. There's way too much math going on there. I go sine is positive, cosine is negative. That puts me in the second quadrant. Sine is 1 over 3. Put my theta here, 1 over 3. 9 minus 1 is 8, 2√2. Since I'm on there, I know it's negative because that's on the negative x. And then I can just do them all from there. And this is the way I would recommend doing it. But you'll get a teacher who says, no, 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 use identities. I even say use identities, but then I actually don't ever use them. Sine of theta 1/3, cosecant of theta 3. Cosine of theta, negative 2√2 over 3. Secant of theta equals negative 3√2 over 4. 3 over 2 root 2 times root 2 over root 2. Yeah, that's right. Tangent of theta, I just did it, but it's a lot easier here. All I have to do is rationalize it. Negative root 2 over 4. And cotangent of theta, negative 2 root 2. I do it by graphing. It makes more sense. It ties the problem together. I'm not just blindly using identities and praying they work out. It's just another way to do it. So do this, pause this and go. I'm not going to do it this way. Sine's less than 0 and tangent's positive, so I know I am in the third quadrant. Tangent's 1 opposite over adjacent. 4 and 1 is 5. This is root 5. This is negative. This is negative. So use the identity tangent squared theta plus 1 equals secant squared. You go ahead and get all 5 of your values, 6 of your values. And I am just going to do it with the graphing. I just think this is a better way to do it. Opposite over hypotenuse. This will end up getting me negative root 5 over 5. That's negative root 5. Cosine of theta, negative 2 root 5 over 5. Secant of theta, negative root 5 over 2. Tangent of theta was given to us. But hey, it never hurts to check, make sure I'm doing it right. And cotangent of theta equals 2. That's how I do it. If you got it over here, hopefully you got the same answers. I would definitely do it both ways. Last but not least, what's it mean to be an even function or an odd function? This is y equals x squared. That's where the word even comes from. I can fold it over the y-axis and it lands right on top of itself. All right? When we get into graphing, you will see that cosine looks like this. And it just folds over itself. So even is going to be cosine, secant, because it's the inverse, and cotangent. Odd is going to be sine, cosecant, tangent. Odd stems from y equals x to the third. And if you rotate this 180 degrees, you'll see it lands right on top of itself. Same thing with sine. If you rotate that 180 degrees, you'll see it lands on top of itself. So that's odd. More on that when we get to graphing. However, you can use that to solve problems. Sine of pi over 6 equals negative sine of negative pi over 6. Cosine of pi over 6 equals cosine of negative pi over 6. And that's one of the properties of odd and even functions. I always go back to the unit circle. It makes a lot more sense to me, and I'm good to go. That's a lot. I apologize for the length of the video. It took a fair amount of time. As always, happy mathing.